Okay. So this is actually an elective subject, which is very interesting in the aspect of wireless communication and high frequency communication. Okay, so this subject mainly deals with MIC and RF system design. So RF, it is the short form of radio frequency, and the entire frequency spectrum is actually the radio frequency, starting from a few hertz to hundreds of gigahertz is radio frequency. But nowadays, it has been a convention to denote high frequency using the term RF. And we are also going to do the same thing only in this unit, where we are going to study about the high frequency analysis of different types of circuits. And MIC, as the name indicates, it might be called as monolithic integrated circuits, or it can be microwave integrated circuits. So all are going to mean one and the same. And normal low frequency, you call it as ICs, integrated circuits. But when you go to high frequencies, these ICs have to be fabricated in a different way. So in that form of fabrication is called as monolithic. So everything is fabricated on a single wafer of silicon or germanium. So that is the meaning of the term MIC. So before proceeding with the unit, I hope the syllabus is visible to you. So we have 5 units in this subject, and unit 1 is going to be the complete basics. Unit 1, I suppose it is the lengthiest of all the units we have in this subject. It is going to be very exhaustive, covering complete MOS basics. You have the different types of noise which can occur in a system. You have the two-point noise theory, the different noise parameters you have, which will measure the effectiveness of a system, and then the architectures for transmitter separately and the architecture for receiver separately. So while preparing the PPT for unit 1, it was almost like I was preparing, and the content was very exhaustive. So obviously, it is very practical that we cannot learn everything and assimilate it in our regular class, and also it is not possible to learn everything in exam point of view also. So we will specifically learn and understand very, very important concepts which are required from the application perspective, and remaining topics can be dealt conceptually. So that would be the better approach to study this subject. So first unit is going to be complete basics of everything, CMOS, MOS architecture. We are going to study about the different types of noises, which will be somewhat interesting because if something is unknown, it will be puzzling to find out what is that, right? So noise will be something very interesting to read. And these parameters, noise figure, THD, IP2, IP3 are also very, very interesting. Some form mathematical formulas and derivations will be there. Architectures, it is going to be block diagram, explanation, spectral diagram. You have to draw the frequency response and say what is the architecture is going to do for you. So this is all about unit 1, and unit 2 is impedance matching and amplifiers. So as you go to high frequency, the problem of impedance matching will occur. So if you don't properly match the impedance, maximum power transfer will not take place. So that is a serious issue which has to be addressed in high frequency circuits. So we are going to do that using Smith chart. And you don't worry about Smith chart. It is just a topic. We are not going to solve any problem using Smith chart. Smith chart is a tool to do impedance matching at high frequency. Then you have the passive IC components. See, the basic components what we use are resistor, inductor, and capacitor. So this is going to be used in any electronic circuit, right? So these components, we think the value is going to be constant. But what happens at high frequency, these values are going to change. So the same resistance at low frequency, which provides a resistance of say 5 ohms, will not provide the same 5 ohms at high frequency. It will start varying. The same inductor which was working very perfectly at low frequency will not work at high frequency.